Section 14.4, linear correlation. Linear correlation. This is an easy section and short. So in linear correlation, we have something called correlation coefficient R. Correlation coefficient R. What does that do or tell us? It helps us to determine the strength and the direction of linear relationship between two variables. So when we draw like the best fit line, this one helps us if the relation or the correlation that we have, is it a positive correlation, negative correlation, or no correlation at all between X and Y. This can be calculated, which we do not want you to do a lot of calculations here, more of conceptual, why we use this, how we use it. It's given by R equals 1 over n minus 1 times the sum of the product of the difference of the x's and the y's, as you can see, divided by the standard deviations of the x and that of the y. And for computing purposes, they use this big formula. Again, as I said, they can give you each one of them and ask you to substitute them in for the homework, but that's it. You don't have to do a lot of work to find each one, then plug them in. That will take a lot of time and easy to make mistakes, computational mistakes. So that's what the correlation coefficient is for, is to tell us or to help us to determine the strength and direction of linear correlation or linear relationship between two variables. If you look at this diagram here, for example, look at the first one here. The first one, look how almost all the points on the line. That's called perfect positive linear correlation when R is 1. When R is 1. So R is going to go from 0 to 1. From 0 to 1. So if you have R1, that gives you like really the best linear correlation. It's called positive or perfect positive correlation. If there's some tiny points off the line but very close, then R would be 0.9. If R is 0.9, that gives us a strong positive correlation. If as R gets closer and closer to 0, do you see how the spread of the points it goes? It's still positive, but it becomes a weak positive correlation. We call it weak positive correlation. So as R gets closer and closer to 0, it gives us a weak positive correlation. Now, can R be below 0? Well, yes, R can go in fact from -1 to 1, not just 0 to 1. So what about if R is exactly -1? If it's exactly -1, it gives us a perfect negative linear correlation because it's going down. So it's going down means negative. If it goes a little bit off the line, then it's a strong negative correlation. And as it gets closer and closer to 0, it becomes weak. And at some point, if R is 0, then it's a really no correlation. So R is always going to be between from -1 to 1. So as you get closer and closer to 1, you get a positive correlation or strong positive correlation. As you get closer and closer to -1, positive negative correlation. And as you get closer and closer to 0, eventually we'll have no linear correlation. That's what we meant by it tells us the strength, like how strong it is, and the direction. Is it positive or negative correlation? Now, in regards to this one, the correlation coefficient R, and the coefficient of determination from the previous section, R square, it says the coefficient of determination is really equal to the square of the linear correlation coefficient. That's what this is. Now, if you look at an example here, they give you a table of values for X and Y. You can find the mean and for each, both X and Y, and list down in a table and do the subtraction. From there, if you do the multiplication and add, that will give us the sum of the products of the difference, as you can see. And then I'll show you on the calculator how to do, or give you a video, supply you with that, to show you how you find the R without going through the computation and stuff. But if you like to do it computational wise, you need to find the standard deviation Sx and Sy for each one of them, for this one and for this one, and use the first formula I showed you. That's one form to start with. You know the bottom ones, we just found this to be 9, and n is the sample size, and then you can find R. Otherwise, if they want you to calculate using this formula, they would give you the values. They would give you the sum of the xi, sum of the xi, yi, and the sum of yi, and the squares of each one of them. And then you will be able to find out, or calculate the R value by simply substituting the y values. The one thing I just noticed here, this should be yi, not xi. So the sum of xi times the sum of yi, all divided by n. I just fixed that formula there. One last note, if the data points are not scattered about the line, means they are off the line, then the linear correlation coefficient is not a descriptive measure for the data appropriate. Like it's just not a good tool to use it here. There's other tools you can learn later on about, but for the meantime, we need to make sure that the points that we have, they are really close to the line. They're not like one here, one there. Like this is not a good plot. There's no correlation basically.